Hello, good evening and welcome to NARC Live on Wednesday the 5th of May 2021 with Tammy M0TC.
Hello, sorry, I'm doing something else.
And me, David G7URP. Great to be with you. On tonight's show, our energy of the future. Find out all about it from our live guests from Ørsted. What has this fine locomotive got to do with radio? And we find out who works from a shack like this. We've had a few guesses, not all right as well. So if you want to have a guess now at the last moment, go on to Facebook or on to BATC and put your guess in there. And we look forward to hearing from you. But first, we've heard from Tom, G8XQD. He says, there's lots of Morse keys and equipment from the past. And then at the end, this is a video that we're talking about here, there's a high speed transmission without any modulation or tone to help identify the dots or the dashes. He says it's all well beyond his attention deficit and dyslexia, self-diagnosed, he adds. Anyway, let's have a little look at it and we'll put a link to the whole video on our newsletter. But here we go. That says the key, I think.
Does it? You translated it
Commentary
earlier,
written by Lou Mario and narrated by Bruce Kelly. Pretty much. I hope.
One of the first forms of communication was the semaphore. It had one definite drawback, however. It could not be used at night nor during inclement weather. This particular one was used by Napoleon in the early 1800s. In England, Cook and Wheatstone developed a so-called needle telegraph. Here, the operators, called needle clerks, many of whom were women by the way, read the position of the indicating needle for the message. All of these methods were slow. This changed in 1844.
Now, I know some of you will be dying to see the rest of that, but it is quite a long video and we're going to send you a link to it. It does seem a bit slow running, but actually it really does cover the history of the telegraph and of course Morse code and the keys and everything that goes on them as well from the beginning. So it's well worth watching. As I said, we'll put a full link to that YouTube video on our newsletter this weekend, so have a look at that. Now, Paul G3VPT wrote to us and said, last Wednesday was another excellent night. And Donard's reference to driving the shunter took me back to my child days as a train spotter on Thorpe Station, when we would wait. I could just feel the glow here. We would wait for the London train to come back, hauled by a Britannia class engine. Q train. There you go. Any excuse, you see.
Yep, any excuse.
This was a lovely picture of this, and this is the Oliver Cromwell. For those of you not into trains, you should be. This is the Britannia class, though, and Oliver Cromwell. This particular locomotive was based a lot in Norfolk. Anyway, I'll carry on with the story. It was hauled by a Britannia class engine. The train was uncoupled, and a different engine would take the train to Great Yarmouth. At this point, we'd asked the driver if he could come up on the footplate, and we always got a ride down to the end of the platform. A few years ago, at a Railways on the Air event, we worked a retired engine driver and related this story, and he told us that he was on that run. And they all did that. Of course, it wouldn't happen today. 7-3 from Paul G3VPT. There we are. And I know what my wife's thinking now. Any excuse to show a train?
Are you sure you've got the right picture there? Because I don't think that's the Oliver Cromwell. I think it is Britannia.
Oh, is it? Oh, yeah. Okay. Did I send you the wrong
link?
And the
picture you've got here is a picture of Oliver Cromwell at Weybourne.
Yes.
Well, that's not Weybourne.
No, you're right.
So I think you've got that completely wrong.
We should have rehearsed in more detail, Tammy.
Yeah.
Anyway, this is a Britannia, and it is the Britannia. It's called Britannia. You're right. It's 70,000. And I think Oliver Cromwell, oh my goodness me, 70,032, I think.
Is it? Somebody's going to correct you now.
Some of they are. Anyway, I'm sorry about that.
You failed.
I know, I have failed, but never mind. I've got to train on to NARC Live, which is the most important thing. Jim or somebody else watching who knows, is it 7,032? I think, anyway.
I'll Google it, shall I?
No, it's okay, it's fine. Anyway, a train. Thank you very much for your feedback, Paul. Any excuse. Now, I just got an advice, and literally about 5 o'clock, I got an email, as many of you who are already registered on the RSGB's tutorial site and involved with training. And if you, by the way, are now thinking about taking your advanced license or any license online, which of course they all are available now, then this is important information for you. The RSGB's Examinations and Syllabus Review Group has just updated the 2 full license mock exam papers. In addition to updating them, there are now worked answer PDFs for these papers, so you can see the correct answer for each question and, importantly, the reasoning behind it. Now, I've never seen them do this before, and it'll be really helpful, especially in these days when you're self-studying and doing a lot of this from home. So these mock papers are provided by the ESRG as a training aid and aren't the exact questions, of course, included in a full licence exam. But foundation and intermediate mock exam papers will have worked answers added in due course as well. So you can find all the mock exam papers on the Society's website, which is at www.rsgb.org. So if you're, especially I think if you're a trainer or if you're thinking of taking an online advanced exam, you would find that very useful, because not only do you get the answers now, but they will tell you how they got the answer. It might help you.
I'm going to butt in now before you go. The people have spoken. It's 70013.
Oh, 13, right.
Yeah.
Am I
That's from
sacked?
Jim, G3YLA.
I thought he would know, because he's very much from these parts.
And I had Googled it as well.
And that is a Norfolk engine. I can't believe, I did look at Oliver Cromwell, I did look at the Britannia class, and I obviously just sent you the wrong link.
Yeah.
We send an email to a special little email address you see we have in this studio, and then we load the pictures up, and we don't always have time to get every single picture. Sorry about that. Corrected I am. It's nice to know that my wife realised it wasn't the right logo, though. Have you noticed that? And corrected me.
I got better eyesight than you. Could see it said Britannia on the side.
Fight back.
Yeah.
Right, thanks. Anyway, moving swiftly on. This Saturday, it's that second Saturday of the month. So it's, is it Saturday, second Saturday of the month? Yes, it is. So it's Koblenz, Sked, our twin town of Koblenz, our twin radio club as well. And we have a usual Sked with them at 10 o'clock BST on 7.135 megahertz. And there's also a local talk-in, of course, on 145.250. That's it for the main club news. Tammy, Little People.
Little People.
I haven't seen this.
Okay,
So
this is
gonna be
actually
new
one
for
I
me.
picked for last week. Then I decided to change it at the last minute. So this is actually last week's choice. This is called a stationary copter. So
That
it's
is
a helicopter
so
made
cool.
out of stationery.
What is the main round bit? Is that a tape measure, do you think?
What, the actual
Yeah.
helicopter part? Yeah, because it's coming out the back, isn't it?
Oh, yes, of course. Isn't that ingenious?
Pretty cool, eh?
2 propellant pencils, a protractor thing at the top. It's wonderful.
Bulldog
As
clip.
usual. Sorry?
Bulldog clip.
Bulldog clip. Oh, yes. I haven't noticed that bit. Brilliant.
Cool, eh?
What ingenuity. There we are. Thank you, Tammy, for finding that. If you want to see more of those, go to miniature-calendar.com. So what have you been doing? Don't forget to let us know, just like Paul and Tom did this week. Drop us an email with anything for the show, radio@dcpmicro.com, and we'll be pleased to feature it, of course. Keeps us in touch with each other. Thank you. Now we come to that part of the show. It's even more excitedly anticipated than the Line of Duty, I reckon.
Is it? Do you reckon?
Yeah, I do think so.
We don't have any bank coppers here, though, do we?
We don't have any bunk coppers, and we don't have anybody named
Bunk
H.
coppers.
Bank coppers either. It is that time of the week when we find out who works from a shack like this. And we've had some guesses. Is there anybody been online?
We
Everybody
have had a
guess?
couple of more guesses.
All right, okay.
Yep. If I just find out which mouse I'm on, because I've got so many here. Sunny says, I don't know if I emailed you, is it Donard, M0KRK, our
Okay.
guest from last week.
Right.
And I'm sure actually I saw, did I see another one somewhere else? Or did I dream it? No, I think I dreamed it.
No, okay.
No, so that's the only
A couple of people
guess.
putting the right number for the train, but anyway.
Yep.
All right, so Sunny thought it was Donard. John GVPE says, I think that the Yamaha Tyros keyboard is a giveaway clue as well. That has to be Clegg, alias Ken M0HGR.
Colin M0GMK. Hi David and Tammy. I don't think we have a Nora Batty on our membership, so I will guess that it's Roy M3NGF.
Okay. And Paul G3VPT. No, I better not say anything at this point. It's Ken M0HGR's shack. And I guess if we hear that music, we should know. Who should know?
So I shall reveal it. It was Ken.
It was Ken.
M0HGR's
Which
shack.
one is he then? I don't really have a fan of
Clegg,
that program.
apparently.
Oh, Clegg,
That's
okay.
what John said.
So you're Clegg. Thank you very much, Ken, for sharing your picture with us. Last of the summer wine game. Lovely.
Ken actually sent us another picture as well last week, but we didn't put it on because we didn't want to give away that it was his shack.
That's true. Yes, so we're going to show you this picture now. Ken just said, have you ever seen a radio like this? Now, there's one thing very strange about that radio if you have a look, and it does say on it one button radio, and the point is there are no buttons or controls. Now, he said this was designed for care homes and places like that, to keep the buttons and controls away from them, because if you now see the next picture, that's what the same radio is. Can we flip back quickly, Tammy?
We can.
So you can see that it's the same radio, but it's got a cover for all those controls. It didn't look so dated, should I say, in the previous picture, but now seeing that one, it looks a bit older. But anyway, thank you for sending that, Ken, and thanks for sending your shack. Let's have a quick look, because we're running a bit late now, so let's have a look at whose shack it is for this week. So who do you think works from a shack like this? A very well-known member of the club. Whose Radio Shack is this? Can you tell by the radios? Maybe the computer? Other clues around there?
The bookshelf.
Bookshelf, yeah. Yeah, there are a few clues there, aren't there, Tammy?
There are.
Easy when you know who it is, of course.
Yeah.
But and a few of the names, of course, have been blocked off the certificates. But anyway, let us know. We're going to put this on the newsletter as usual, of course, and on our Facebook page. And let us know by next Wednesday at 3 o'clock in the afternoon at the latest. But if you think you know it is now, drop us an email now to our usual address, radio@dcpmicro.com. Whose shack do you think that is? Just got time now to tell you what's happening at the club this week. On Saturday, May the 8th, as I mentioned, it's Koblensked at 7.135 megs at 10 o'clock. GB Tourist News on Sunday at 7 o'clock on GB3MB as well. Also on Monday, 10th of May, it's the Monday Night Net, and it's open to everybody. And this week, it's all about food.
Food?
Again, food, apparently. If you can go out to a restaurant right now, what would you order?
Pizza.
I wasn't asking you, I was
Okay.
asking them. Anyway, yeah, what would you order? That's one of the subjects that you can talk about. And of course, anything else as well on our informal net on a Monday night. At 8:30, it's the 80-metre CW net. And next Wednesday, the 12th of May, here on NARC Live, it's called the Hail Cycle. Now, I must admit, I didn't know what the Hail Cycle was. Our guest, though, is Dr. Scott McIntosh, who's the Deputy Director of NCAR, which is the National Centre of Atmospheric Research. And the Hail Cycle consists of 2 successive 11-year solar activity cycles of opposing magnetic field polarities. And he's coming here to tell us all about it. And of course, the effect it has on our hobby as well. Plus all our regular features, your stories and your pictures as well. Please send them to us. Now, one other thing, we normally tell you just what's happening next week. We're going to tell you what's happening in 2 weeks. You may remember last month, in April, we were promoting to you and telling you, please, we're going to be doing a wildlife nature special. And that's coming up on the 19th of May. So that's 2 weeks tonight. That's a picture from our garden from, well, in the slightly colder times, of course. We've been asking you to keep an eye out for pictures of nature. Maybe they can be flowers, plants and things like that. They can be animals, of course. And we don't call it Spring Watch.
No.
Some other bigger organisation has got the name of that. So we thought we'd call this Spring View. So if you've got pictures that you've already taken, please send them to us. A couple of you already did, I know. But most importantly, you have 2 weeks now to send us to us. It will be an interactive, so we'll be able to have you here on the screen and you can talk to us as well, even send us pictures then. But we'd like to see lots of pictures and videos. We do need those in advance. So if you can start thinking about that, keep an eye open, take your camera with you, take your phone with you, taking pictures of nature, spring where you are, for Spring View in 2 weeks' time, and send them to that address, radio@dcpmicro.com. And similarly as well, of course, we always mention this card, which we send to anybody you know who would appreciate a card. We sent one to a gentleman this week who's been in hospital, and we were asked by somebody to send it to him, and it really cheered him up. We got an email from him today. So if you know anybody who would be cheered by a card like this, whether it be an anniversary, birthday, just not feeling very cheerful with life or anything like that, to have received this card from your club, just send us an email with their name and address. Now, just a tiny bit later than we promised, we have we're very pleased to welcome a couple of guests tonight to talk about wind offshore energy. I'm sure we've all seen wind farms, but we may not know how they work. We may not know how they affect us. As well as the environment issues, which I guess affects everybody, for us as radio amateurs, of course, this sort of thing can affect us maybe, and we're hoping to get some answers to that tonight. But first, we're going to see a presentation from the Ørsted company, who've won a contract or won a bid to run a new line between Weybourne and Swordston in the near future. And we've got a couple of representatives from Ørsted with us tonight, so let's welcome them now to Emily and to Ant. Hello.
Hi David, and hi everyone. Thank you very much for having us and inviting us to come and provide an update today on our latest project that we're developing in Norfolk. Really excited to be here with everyone today.
Yes, we're really looking forward to it. I should mention as well, Emily, before you start your presentation as well, that we did, of course, ask people to send in some questions, because we know it's quite a complex subject. There can be quite a lot of technical detail, and a few people did do that for us, so you'll be answering those questions later on. We might be able to take a few general questions here, but if they're not questions that you can answer tonight, of course, we will forward them to you, and we'll also give you contact details at the end. But now let's go back to Emily and to Ant for a presentation. Firstly, to find out what Ørsted is all about, what the project's all about. Over to you.
Great, thank you. And can I just check you can see the presentation on the screen? Yeah,
that's fine, yeah.
Great. So yeah, thank you very much for having us. I'll just briefly introduce myself and then hand over to Ant as well to introduce herself. So I'm policy advisor at Ørsted, and I've been working here for almost 7 years. On a number of different projects, but I work in kind of in our policy team, looking at future energy and offshore wind as well in particular. Ant?
Thanks, Emily. Hi, everyone. Thank you for having us. So my name's Ant Sahota. I am the Onshore Environment Manager for Hornsea 3. So I've been with Ørsted approximately 3 years and have worked on a couple of projects at my time here. And I'll be responsible, I suppose, for the onshore discharge of the legal requirements as we move into pre-construction and into the construction phase.
Great. So just first of all, a little bit of background on Ørsted as a company. For those of you that may not be familiar with us, we develop and construct renewable projects across the globe, with large-scale renewable electricity projects operating or underway in Northwestern Europe, the United States, and the Asia Pacific as well region. In the last decade, we've undertaken a green transformation, and in the 2000s, a complete green transformation. In the 2000s, we were one of the most coal-intensive power generators in Europe, with an expanding oil and gas production business. But we took a strategic decision several years ago to become a green energy company, focused purely on green renewable electricity. And to drive the transformation, we've invested heavily in renewables over the past few years, particularly in offshore wind. We've exited our fossil fuel business and formulated our vision, which is on the screen, to create a world which runs entirely on green energy. So I'll pause here, and if we can put up the step-by-step video, and then we'll carry on with the presentation. Thanks.
Okay. Just give us a moment to press the right buttons. Here we go.
Imagine you were asked to change the way we power the world. It might seem a bit overwhelming at first, until you remember even the biggest changes happen one small step at a time. One gear, one bolt, one circuit at a time. One click, one test, one advancement at a time. One machine, one better machine. One bigger, better machine at a time. One person, one team, one small step at a time. From the world's first offshore wind farm to its biggest, we've been working to create a world that runs entirely on green energy. Because little by little, big happens. Ørsted, love your home.
Back to you, Emily.
Great, thanks, David. So we've that's a bit of a video showing some quite interesting components of an offshore wind farm. So I thought it'd be quite interesting for those of you not familiar with the technology to have a look at. So as I mentioned, over the past decade, we've undergone a significant transformation as a company. Since 2006, we've reduced our carbon dioxide emissions by 86%. And by 2033, we will be completely coal-free, with a target by 2025 to have reduced our carbon dioxide emissions by at least 98% since 2006. So we've got a long way to go, but we are making great progress and towards our goal. And just to give a little bit of an overview in terms of our global footprint. So we're globally the leader in offshore wind with 7.6 gigawatts of constructed capacity, and a further 2.3 gigawatts of capacity that's under construction, and that's across our different markets. So the UK, Europe, and also North America and Asia Pacific as well. The UK is by far our largest market, and we've got 12 operational offshore wind farms. A further project in construction, which is Hornsea 2, which you can see towards the east there, it's just off the Humber, and several other projects which are in development, including Hornsea 3, which is the project that we'll provide a bit more information on this evening to you. Ørsted UK has 1,000 employees, over 1,000 employees, based from a number of sites. So we've got our headquarters in London, but we also have a number of operational hubs in Grimsby, Barrow and Liverpool, and also at Gunfleet Sands, which is near Chelmsford. So we've got a strong pipeline of projects in the area, and to date we've invested 10 billion building these wind farms over the past decade, and expect to increase that, obviously entering into the 2020s as well. And by 2022, our operational fleet in the UK will provide 6% of the UK's electricity. That's a little bit of background. And as you can see, we've got 30 years experience and strong track record of building and operating offshore wind farms, having built the first ever offshore wind farm back in 1991 in Denmark. So I think reflecting on where the industry has come, we've made huge leaps and bounds in the last decade and more, particularly, and innovation has been absolutely key to that. So I always think this is quite an interesting slide to show, just in terms of how those turbines have increased in size over time. Back from Vindeby, which is our first project that was constructed in 1991. Up to the latest ones that we're installing at our current or most recent offshore wind farms across the UK. And just to give a sense of the scale, you can see the image there with comparing some of the turbines to landmarks or well-known landmarks, and you can see how they have increased significantly over time up to the kind of latest model, which is the 12 megawatt turbine that is currently in line to be installed at the kind of latest wind farms of the UK and also in the US. So hopefully I've also got some more pictures later on which we can kind of have a look at, which also give that sense of scale. But it is, these are significant infrastructure projects, and do, it takes a lot as well to install and operate these on an ongoing basis. So for some context, as well as the heights increasing, the blades are also getting larger, and so long, some of them are as long as 75 meters, which, for context, would be about 8 kind of double-decker buses back to back. So yeah, it's incredible pieces of infrastructure. And what this innovation and also expansion of the industry has led to is a rapid cost reduction that we've witnessed, to the point where offshore wind is now competitive relative to conventional power generation based on fossil fuels. So you can see kind of offshore wind costs compared to other technologies there. And a bit of context, this has kind of been primarily driven by 4 key aspects. So first has been scale. So we've talked about kind of the innovation, but also just the amount of projects coming forward and the capacity that we've seen. So we've seen, particularly across our portfolio of projects and wind farms in the UK, we've been able to kind of benefit from economies of scales and mass production of components and other things, which has enabled cost reduction, both on a kind of construction element, but also on the operations side of things as well. We've also seen the industry maturing and technology innovations across all kind of areas of the wind farm, and we can go into the different components in a bit more detail in a second. So that's been another key driver, and we continue to see innovations across different areas of the wind farm components, so including cables, turbine designs, which we've talked about, and new models being brought out to market, new installation equipment materials, continuous improvement on foundation design, looking to kind of optimize the amount of steel required to support the turbines in place offshore, and general kind of learning and growing in capabilities across the supply chain, of which there are lots of very good suppliers in the UK as well. We're seeing synergies. Oh, sorry, let's jump ahead. Synergies across our projects. So you might have been able to see from that kind of image of our projects across the UK that we're starting to see these clusters form. So we're able to optimize our O&M solutions. And finally, risk reduction. So obviously, having 30 years plus experience, we are starting to we're able to build on those lessons learned from previous projects, scale up and put that into practice for our current projects. So we're continually learning and refining and able to kind of reduce that risk associated with projects as well, which has helped with cost reduction. So I'll just come on to a bit of a kind of a diagram just illustrating the components that make up an offshore wind farm and how we transport the green electricity generated at our wind turbines to homes across the UK and businesses as well. So when the wind blows, the blades spin, turning shafts inside the nacelle, which I can point out in one of our images coming up. These shafts then connect to a gearbox, increasing the speed of the shaft that drives the generator. The generator uses the rotation of the shaft and the principle of electromagnetism to then generate electricity. And this electricity is then transported or transmitted by cables buried in the sea to an offshore substation, typically kind of located near to the array area where you have all of your turbines. Upon reaching the substation, the energy is then stepped up to a higher voltage before being transferred to shore via high voltage cables. And at the high voltage, it can be transmitted with fewer losses as well. So once it reaches the landfall, the electricity is then taken to an onshore substation, which is marked there, kind of in the middle, taken to the substation where it's then again transformed so it can be enter the national grid electricity system. And you'll also see then at that stage when it's prior to going to being distributed out to homes, it's reduced to a relevant level for them. So I'll just move on. So this evening I wanted to kind of just pull out a couple of images of some of the wind farms that we've worked on, again to give that kind of sense of scale of the infrastructure, and just talk you through these. So this first one you're seeing a kind of jack-up vessel, so it's a sea jack vessel that we use to install the turbines. So you can see the blades stacked up there on the vessel, and these kind of ginormous cranes here that are used to connect the blades to the nacelle. And some of these obviously are already in place. And just the second image is the image from the top of the turbine. So this is what most of our wind turbine technicians will be able to see on a kind of daily basis when they go out to work. So some incredible views, particularly when the weather is good and you've got lovely clear skies. And then this is an interesting one. It's at our Hornsea 1 offshore wind farm, which is currently the world's largest offshore wind farm at 1.2 gigawatts. And it's photographs taken kind of obviously up towards the turbine, looking down at the base of the 7 megawatt turbine, and the Edda Mistral service operational vessel. And it kind of gives the sense there. I think you might just be able to make out a very small person just there by the base of the turbine and the transition piece. And these service vessels will be where our kind of team of wind turbine technicians are kind of based during the operation. Some of this Hornsea 1 in particular is very far from shore, so you have all of your technicians based offshore, so that they can readily maintain the wind farms. So it's 120 kilometres offshore, and just context, this is one turbine out of 174 turbines which make up the Hornsea 1 offshore wind farm, and can provide power to over 1 million UK homes. So this one's currently operational. I've provided a link at the end of the presentation, and we can also, I think David's going to circulate it around to your newsletter. But there's a video as well if anyone's interested in kind of understanding a bit more about what it's like to work on a service operation vessel, and the kind of day-to-day activities of a wind turbine technician. Let's move on. This next one, I think within the kind of theme of innovation, I mentioned that we're continually seeing innovations across the sector, and this one's particularly exciting. It's one of our technicians using the new Get Up Safe motion compensated lifting system to access the turbine. So it's a unique solution that allows access to the turbine with no boat landing, as we saw in the previous one, or ladder from any crew transfer vessel. So with the motion compensated hoist, the technicians will be lifted directly from the boat, removing the need for ladders and boat landings altogether. So this is one of the kind of game-changing technologies that's being introduced in the industry, and there are others continually as well, and will revolutionise the way that technicians get to work. And just for context, I thought I'd show this image here again for the kind of scale of these turbines, but to see the traditional way of accessing turbines versus obviously the Get Up Safe system. So that was a little bit of a background on Ørsted, and on some background on the industry itself, and hopefully gives you a kind of a sense of the direction of travel for the industry. And as many of you may be aware, that there are government targets now to bring more offshore wind farms to the UK. So they've set the target of 40 gigawatts of offshore wind by 2030. So that's going to be a lot of deployment over the next decade. And creating kind of huge number of jobs across the UK in low carbon technologies. I'll hand over to my colleague Ant now, who's just going to give a bit of an introduction to Hornsea Project 3, which is our latest project that we're developing in Norfolk.
Thank you, Emily. Hi again, everyone. So just a bit of thanks for that. Just a bit of a background on Hornsea 3 specifically. So once the project is built, it'll have an operational capacity of at least 2.4 gigawatts. So as Emily touched on, it'll go a long way to achieving our UK government targets of 40 gigawatt of offshore wind capacity by 2030. In terms of carbon, that means generating around 128 million tonnes of offsetting 128 million tonnes of CO2 over its lifetime. So the actual array is in the Dogger Bank region in the southern North Sea, and it forms part of the former Hornsea zone, or what used to be called the Hornsea zone. So as Emily touched on earlier, we've got the Hornsea 1, which is now operational, recently became operational as of last year. Hornsea 2, which is still in construction, so we're just sort of wrapping up the onshore construction and undertaking the reinstatement, and have embarked on the offshore works now. And Hornsea 3 is obviously our project in Norfolk, and Hornsea 4 coming behind us is a development project, but don't worry, it's in a different region. It makes landfall south of Bridlington and connects into Creaky Beck in East Yorkshire. In terms of Hornsea 3, we're now sort of moving into construction, the pre-construction stage, now that we have consent to build. Would you mind moving to the next slide?
Yes.
Thank you. So offshore cables make landfall near Weybourne, as you're hopefully familiar with, and a run for approximately 56 kilometres around the west of Norwich, and down to our HVAC or HVDC converter station, which is located just west of the Norwich main substation, National Grid substation, near Swardeston. The next slide, please. Oh, and you can, sorry, the link there has been provided, is a bit of an interactive map. So if you're more interested in finding out where the onshore route is in relation to the areas you're interested in, or your locality, it's a really handy map actually, for you to find out where the project is located, and shows you the different type of infrastructure and where it is. Next slide, please. So in terms of the onshore substation, so this is what we call the HVAC or HVAC/HVDC converter station. So you can see our cables come in west of the B road. The brown area in the middle is where we will have the maximum extent of the permanent infrastructure. The green areas are where we have visuals. We basically have that area earmarked for visual screening. So we'll plant up and we'll develop those plans for maybe bunding or maybe some attenuation ponds, potentially look at some enhancements to screen the substation. And then you can see the cables. So we'll have a maximum of 4 circuits of 400 kV cables running into the National Grid Norwich main substation just south of it and just sort of southwest of Dunstan. Moving on to some of the key project updates. So we recently sent out a newsletter, and we just want to sort of update the community on where we're at the moment. We are very much in the beginning stages of the detailed design process, and we're sort of exploring what solutions for certain types of for certain points in the project, what solutions might be viable and technically feasible. So I think what we've come to conclude is that at the moment our preferred method for installing the cables at the landfall, so that's bringing the cables offshore, onshore to the beach, underneath the beach, is via horizontal directional drill. So we'll look to mitigate any open cut of the cliffs, hopefully, and to drill underneath the seabed instead and underneath the cliffs. That is still subject to some further technical investigations. That's purely sort of to understand whether it's technically feasible to install the cables in that manner. The second sort of main announcement was that we have a preference for an HVDC solution. I think you guys are probably all aware of that. So that removes the need for remove the need for an onshore booster station. We had one within our project envelope, and indeed it was consented, but we would only really look to use that in an HVAC solution. So we hope to have sort of mitigated and reduced the impact of that booster station in that respect. It also means fewer circuits potentially, and hopefully what would be a narrower cable corridor width. So generally you'd look to have 2 cables sitting alongside one another rather than 3 cables in a sort of a 3 cable like a triangular formation in each of the circuit trenches. Moving on to the next slide. Thank you. So just moving on to the broad programme, or the planned programme for Hornsea 3. So we gained consent in December 2020, and as I said, we're refining the project programme and preparing for sort of the detailed design and sending RFIs out to potential suppliers and understanding how the details of our project are going to play out in practice. So we could be looking at construction as early as 2023, and we could still be a maximum of 2 phases. Onshore, our main focus is engaging with statutory stakeholders, and particularly with the local planning authorities, to understand how we can develop our environmental mitigation and our management plans as we move forward. We're also working very closely with other developers and coordinating with other nationally significant infrastructure projects which are in the area, and we definitely understand that the region is busy, and there are potential overlaps with various developments in the area, and we are proactively engaging with those developers to understand how we can work together, and in turn are working with the local authorities, whether that's Highways Authority or the local planning authorities, to understand how we can mitigate and again coordinate on that. We're also preparing for pre-construction surveys. So this year we'll be undertaking various site investigation surveys, some environmental surveys, land drainage surveys in the coming months, and these will sort of continue into next year as we move into construction. So we can understand again more about what the physical environment looks like prior to construction. That in turn will tell us what our mitigation needs to look like as we develop our plans with the statutory stakeholders, but also will tell us how we need to design the project at various key points across the project. I think that's everything from me. Thank you.
And then I guess one of the other elements, so for those that do live within the kind of vicinity of our cable corridor routes and have received our latest newsletter, well, if you haven't received it, it's available on our website, and we can also provide a link. But for those who have, you may have also seen that we have kind of announced our intention to establish a community benefit fund for Hornsea 3. So this is quite a typical thing that we've done as part of our community engagement programs on a number of our wind farms. So we currently have 3 community benefit funds existing, 2 on the west coast and 1 on the east, linked to kind of Hornsea 1 and Race Bank offshore wind farm. And combined, those benefit funds provide £1.3 million funding a year to community initiatives, and that ranges from environmental projects to community builds, but also to supporting kind of skills initiatives in the regions where we operate as well. So it is our intention to do one for Hornsea 3. It is subject to the project taking a positive financial investment decision, and the next step for the project is to participate in an upcoming contract for difference auction, which is the subsidy regime for renewable energy projects in the UK. So if we're successful in an upcoming auction and we progress to that next stage, which is making that positive and financial investment decision, then it would be our intention to kind of launch a fund as soon as we could. And I guess just to give you a bit of detail about what that would entail for local communities, we would do a consultation prior to kind of establishing the fund to understand how best to shape that and what types of projects it should be spent on, the funding area, and kind of just to make sure that it's fit for purpose for the region. So that would include things like an online survey, face-to-face and one-to-one meetings with various groups across the area, and also a series of in-person, if it's possible to do that by then, in-person events where we can go around and kind of exhibit the feedback that we've had from the consultation, and to kind of share and our views, and also get further input from communities on what they would like the fund to look like. So we are very hopeful that if all things go well, we would hope to establish a fund and have it up and running within the first year of construction, the wind farm. And we have, if you want any further information on our existing funds, one of our funds does currently extend actually into North Norfolk as far as Wales next to the sea. We've provided at the end a kind of link through to our community benefit fund section of the website, and also the latest newsletter, which gives you a sense of some of the projects that the funds have supported. The other thing that I wanted to cover as well this evening is how we'll be engaging with local communities going forwards. So here on the screen, you've got a couple of the core methods of engagement that we always look to employ across our projects. So appointing a community liaison officer to be on hand and available during the construction period if there are any issues that arise, or if you have any questions relating to the construction works for our plans. So they typically are, based at the kind of construction site. So that'll be within Norfolk, and we're looking to kind of appoint someone locally. So they've got that local knowledge and can assist with any issues or requests. We'll also have a communication support team, so having a 24-hour phone line if there are any issues that arise as we construct the project, and also keeping communities informed throughout. So through our quarterly newsletters, providing regular updates on what we're doing across in the lead up and during the construction phase, other activities, and any insights into kind of how we're working and plan to engage with communities. And the final thing, again, which is one of our kind of critical things that we do really enjoy doing, particularly when we're delivering our projects, is events. So we're very hopeful that by the time Hornsea 3 comes forward, we'll be able to kind of come back out to Norfolk and meet people in person to provide kind of community information events. So that will include, prior to construction, a series of events where we'll be able to provide further information on the work that we're intending to undertake. But also we have historically run topic-specific events if there's an area of interest. For example, we are running an archaeological event for our Hornsea Project 2 event, 2 offshore wind farm. So where there are those kind of topics, there's potential to consider other events as well. So I think this is just some useful links. I think David is planning to send them around as well as part of an email or a newsletter. But there's a few links in here to sustainability reports that provides a bit more background on Ørsted as a business. Our Hornsea Project 3 website, where you can find the newsletter and other updates on the project. Our job site as well, if anyone is interested in a career in renewable energy. And also the community benefit information that I mentioned just now. And also two links to some videos that we haven't watched today, but if you're interested in understanding a bit more about what it's like to work on an offshore wind farm, there's 2 videos that kind of talk you through the day of a wind turbine, and also what it's like to work on the service operations vessel. That's the end of our presentation today, but we're very happy to take some questions that I think David's collated in advance.
Yes, thank you very much, Emily, and to Ant as well. And we'll be coming back to you as well. As you said, as we asked last week for people to submit questions in advance, and we've had, I think, 9 questions, in fact, in total. two of which are very similar so we're going to combine those, and I'll read those to you first. I know we've got a couple of points coming up on BATC and on Facebook, a couple of questions, and we'll see if you can answer those as well at the end, but let's see how we get on. So firstly, question 1, has the transmission technology been used previously, and what EMF radiation levels were encountered? That was from Steve, G3EVA. And also I think, Emily, you said that it would be better to also mention this because it's such a similar question from Mike, G4DYC. He asks, with reference to electromagnetic and EMF fields, can Ørsted officers please state what studies and or modelling have been done in this specific proposal regarding distance from the power feed lines and ancillary equipment, e.g. transformers, etc., such electromagnetic radiation will be detectable, and at what field strength? So very similar questions 1 and 7. Over to you.
Great. Do you want me to cover this one? So I think on your first question about, so has the power transmission technology been used previously? As Ant mentioned in the presentation, we have announced kind of in our latest newsletter kind of preference to use high voltage direct current for the project. We applied for consent for both high voltage direct current and high voltage alternating current in our application. And I guess high voltage alternating current is the kind of principal means of transmission in all kind of modern power systems. And is the technology that all operational wind farms currently use. So that's the vast majority of all electricity is generated and transported using alternating current. High voltage direct current is an alternative to high voltage alternating current for point-to-point power transmission, and maybe more appropriate in certain circumstances for kind of bulk transfer over longer distances or between different grids. So, for example, it's been used for interconnectors between different countries. So if we used high voltage direct current, which is our current preference, that would be a kind of a new technology. It's new to Ørsted in the UK. However, there are other developers that are currently installing the technology. So it's obviously a kind of slightly different fit for wind farms, but a kind of a technology that's maturing and is particularly being used more and more for wind farms that are further from shore. So a bit of context there in terms of our choice of technology. In terms of electromagnetic fields, the onshore transmission infrastructure will generate electric and magnetic fields when in operation. So the high voltage alternating current infrastructure will generate electromagnetic fields principally at 50 Hertz, and the high voltage direct current infrastructure will generate static fields at 0 Hertz. And these types of the 50 Hertz electromagnetic fields generated by this type of electricity transmission are often referred to as power frequency or extremely low frequency EMFs. And they're produced wherever electricity is generated, transmitted or used. So public exposure to these types of EMFs therefore comes from a wide range of sources in the human environment. So what we've done as part of our consent application is to prepare a document which is part of our environmental statement. And it's our EMF compliance statement, and sets out, provides a kind of an assessment of the static and the extremely low frequency EMF that would be generated by the Hornsea 3 onshore transmission infrastructure, giving kind of maximum predicted field strengths to assess compliance with health protection guidelines for public exposure to EMF. So that document is available online, and we can share a link to it as well if the group's interested. But that has further information about how we will ensure that the project's compliant with public health guidelines. I know there's some other questions as well relating more to whether there's any interference with communication lines. That's not covered in that specific report, but we can cover it in the latter questions as well.
Sure, okay. Thank you. Thanks for that, Emily. By the way, I'm just trying to cover a couple of questions there. I think Alec Adams on Facebook has asked, will the supply from Weyburn to Swanston be AC or DC? If DC, would inverters be used? I think you've probably covered that as well in the answer. So let's go on to question 2 that was asked in advance. How is the energy transmitted? 3-phase AC, DC pulse, or if AC, what is the frequency, and is it a pure sine wave? And are there harmonics generated at the inverter if one is employed? That's again from Steve G3VA. Is that one that you can answer? I know there was a couple, by the way, that you're waiting. To be fair, I should explain to everybody at home, in fact, here that our colleagues at Ørsted have only had these questions for about 24 hours because Monday was a bank holiday, and we asked you to send your questions by Monday evening. So to be fair, they may not have answers on all of these things, but you can appreciate it can be quite a technical subject. Anyway, I'll hand back to Emily or to Ant to maybe if you can answer any of that one.
Yes, so I guess the key thing here is that, as Ant explained, the project's still very much in development phase. So we have, as we talked through, indicated our kind of preference to use direct current to transmit the electricity from the wind farm to shore and to the substation. Further work is required, and discussions with suppliers to understand kind of the frequency, but we'd be able to kind of take this particular question away and come back to the group and apologise that we're not able to answer all the technical questions this evening, but please do continue to send those types of questions through, and if we're not able to provide it this evening, then we will come back to the group and provide that.
Sure. No, thank you very much for that. The other question that Steve G3VA has sent us is, at what depth are the cables placed, and will there be transformers or inverters at points along the transmission route? And also, coincidentally, one of the questions, which I know people at home didn't realise what had been asked at this point, Robert G at SDU says, how deep are the cables on land? So I guess you can answer both those questions at once, maybe.
Yeah, I'll hand over to Ant. You want me to put up the diagram as well?
Yeah, that might be helpful. Thank you. So we have consent to install up to 6 export cable circuits. So that will be in 3 trenches. So for the HVDC solution, as I said previously, that'll be 2 cables along next to each other, and for the AC it would be a formation of 3. The alignment may vary according to the design or where we're crossing obstacles, and depending on the locality. The cables themselves consist of copper or aluminium conductors wrapped with various materials for insulation and protection and sealing, and they'll be buried at a sort of a target burial depth of 1.2 meters. So this is a target depth because generally the ground conditions might vary slightly, and that's generally measured to the top of the tile. So as you install the cables in a trench, you backfill it and normally put a protective tile and then tape on top of it. So that's generally how it's measured. Where we horizontally directionally drill obstacles, so for example the acronym for that is HDD. We HDD major watercourses, major roads. The cables will be buried deeper, and I generally what we'd do to install those is to install ducts, and we would pull those through using an HDD rig, and then we would pull the cables in turn through that duct, and then joint the cables either side of that HDD. For the HVDC solution, no converter stations are required onshore. So that means the only converter station would be near the substation at Swanston, and then the 400 kV connection will be a maximum of 4 circuits from our substation into Norwich Main. The cables are generally installed in sections of anywhere between sort of 750 meters and 2,500 meters, and that's very much depends on things like how constrained the road network is, whether we can get the cable drums in, and also whether we can actually manufacture and put the cables on the cable drums in in the manufacturing facilities. Apart from that, so once they are delivered in sections, they're generally jointed together at what are called jointing bays. So these sit beneath the surface, and some of the jointing bays would have adjoining link boxes. So those are just sort of at ground level inspection boxes. So if something were to happen, which is very rare because we monitor the cables, so generally we would put in a fibre optic cable in with the cables, and we would monitor everything remotely. But say on the off chance we needed to go and inspect the cables, we would use the link boxes to then get into some of the joint bays. That sort of design isn't that's sort of like a general idea of how we construct the wind farm, but the actual detailed design of where these are all located is very much will be decided in the coming years prior to construction.
Okay, thank you very much.
Just to add,
Just
to add to Ant's response, I guess just that, we have talked about the cables for the wind farm are going to be buried underground, and relating back to the kind of electromagnetic fields questions, a byproduct of the design of the high voltage underground cables is that the electric fields are shielded and not measurable above ground. Although the maximum magnetic field strength from underground cables is greater, or can be greater than overhead lines, due to the kind of cables being closer to ground level, they also decrease more rapidly with distance away from it, mainly because the conductors of the cables are closer together. So just something to add in terms of that, the EMF question as well.
Thank you, yes. By the way, we did have a comment from a couple of people, and just to explain about the slides, on some of them, there's a lot of fine information, which by the time that we've got the picture from you and then we've rebroadcast it, as it were, then I don't think some of those details are available. Are some of these slides, like the one you've just shown there, which was shown at the beginning of the event, are they available on the website as well?
Yes.
Sorry.
It was the slide and we put up with the illustrative kind of cable layout across the cable routes. That is part of our project description, but we can provide links to that. So all of the documents and images that we've shown are kind of, most of them are part of the application that we did for our consent. Fine.
All right. So I know there's a lot of information on the website, and thanks for clarifying that. Question 4 now. This was from Roger G3LDI. Radio amateurs have long experienced causing interference to television when it was on 50 megahertz. Now the situation is reversed and exacerbated by the import of cheap Chinese products, like switch mode power supplies, solar panel inverters, to mention just two. Although they have a CE mark, the suppression components are left out in imports, with the test item the only one with them. Our concern is how these installations will affect us from the interference aspect. The substation will be very close to my own place in Swordston. If inverters are used, where I am concerned is that the interference may be enormous. The ones used in solar panels are bad enough, but these could mean the end to my hobby. Will there be any control over this? And if so, what are they? And will checks be made on amateur frequencies?
Thanks, David. So yeah, on the kind of potential interference, as I mentioned, it's not covered within the EMF compliance statement, but it's certainly something that we can explore further as we get into the technical design work for Hornsea 3. It would be great if, in order to kind of inform our discussions with the internal technical team and also potential suppliers of DC technologies, if we could understand the location of any equipment used by members of the group, and also the kind of frequency bands that you're using. And if after this presentation people are happy to share this information either with David or directly with us via our project email, we can take this away and ask the question to those teams. As we said, we're still very, kind of an early stage in development with further technical work required, but it's certainly something we can look into for the group.
Okay, thank you. Yes, I note that your preferred method is going to be DC, and if it's DC, then we know that in our homes, of course, we use AC. So at some point, presumably maybe at that substation at Swordston, it's going to have to be converted from DC to AC, and I guess that's where Roger and others might be concerned that there might be interference. Is that your understanding as well?
So our converter stations would be offshore, and then they would run to the substation onshore, and basically, I suppose, change the power into ready to go into the Norwich main substation.
Yeah.
I think that's about as much of the technical details I know, but I know that our converter stations are offshore.
Okay, I guess, yeah. And I know, and I just put that in just because I know that a lot of people at home would be concerned about that. But we'll certainly take you up on your offer of letting you know what probably all of our amateur radio frequencies are in the UK. I mean, they are fairly easily available, I think, from people like Ofcom. But I'm certainly that Roger and others concerned as well may want to send that information. If they send it to me, actually, at the club, then I'll collate the information and send it to you, so that your engineers can consider that at the design stage. So we're on to question 5 now. With the current, this is from Rodney, G0CBO. With the current amount of building work and new roads being constructed across the county, my concern is the impact on the environment. Do Ørsted have an environment plan along with advisors? It seems that a lot of projects seem to be tearing the county apart. What is your company's policy on environmental issues? He's not a green warrior, he says, but we all have to share this planet and respect all forms of life. As I said, that was Rodney, G0CBO.
Yeah, so I think when we are developing the project, and our primary mitigation is via the design of the project. So when we develop the initial design for the project, we seek to mitigate and ideally, where possible, avoid environmental impacts and impacts to people altogether. By sort of streamlining the infrastructure within the design and through our route planning and site selection process. So when we go through that process, we undertake an exercise in understanding what those possible constraints might be with the existing data, and we do things like route around designated sites or mitigate traffic issues on certain areas or certain communities. However, where that's not possible, we do undertake a full environmental impact assessment and a habitats regulations assessment for the project. And having undertaken that impact assessment over the last, I think it's been 3-4 years now, with some delays as well as a result of the compensation we've provided as a project. We seek to then identify the potential impacts which might occur, so that includes people and the environment, and then we establish whether there are any likely significant effects. Now, where there are potentially likely significant effects, we then develop and we work with statutory nature conservation bodies, the local authorities and any other relevant stakeholders to develop that mitigation in consultation with them. And we seek to agree that with them. We're then examined pretty thoroughly on all of these environmental impacts and questioned and really challenged, I think, in a really good way to prove that what we are providing is robust. And as we now move into the detailed design stages of the projects, we'll continue to work with those local authorities and, again, where relevant, the statutory nature conservation bodies, to develop any further mitigation and ways of working to further limit the impact. And that will work in tandem with our detailed design. So as we understand more of the project, we'll keep talking to these stakeholders to understand what is to provide what is required and seek their views on that as well. So our intention is definitely to mitigate any potential impacts of the project as far as possible.
Okay, thank you. Question 6, also from Rodney, G0CBO. I think this is a really exciting time to be involved with offshore energy, and if I was having my time again, I'd enjoy the challenge of working in offshore energy. What training do you offer others who might be considering a career in this industry, and do you offer apprenticeships and training for new employees?
Thanks, David. Yeah, that's a very exciting time to be working in the industry, and there are a range of jobs, diverse jobs available across all different parts of the industry in both kind of professional and technical roles. So we've talked about things like wind turbine technicians, but also a lot of roles, engineering roles that are involved in some of the work, obviously, that Ant's talking about, as well as kind of environmental specialists feeding into those consent applications, and a variety of roles that are kind of office-based as well. We're in the process for Hornsea 3 of developing our skills strategy. However, we do have a lot of skills initiatives that we do across our existing portfolio of wind farms and at a kind of UK level. So one of the things that we have is that we've partnered with a number of local training providers to offer offshore wind turbine technician apprenticeships on the east and west coast, where we've got those existing regional hubs, and that's a 3-year apprenticeship programme combining kind of a 1-year classroom-based learning, but also 2 years working on site with Ørsted. So they've got that kind of hands-on experience. And at the end of that training, they'll earn a maintenance and operations engineering technician qualification, which incorporates a kind of BTEC level 3 in engineering. So that program's been kind of ongoing since 2017. And so far, we've had 33 people who have been accepted onto the program, and 4 that are now completed and working offshore. And I think what we're seeing across the industry is that we're really trying to make sure that we advertise these roles to a diverse range of applicants. So not only kind of diverse in terms of age ranges, and we're seeing a lot of people now that are applying for apprenticeships that are slightly older and maybe actually are progressing, have had one career already, so they're transferring skills into the new sector, but also more of a mixture in terms of male and female apprentices as well, which is great. The other things that we do, we've talked a bit about the Community Benefit Fund, but we do try and support local skills initiatives, whether that's kind of actively going out into schools and presenting and educating school leavers on the opportunities within the sector, but also trying to support programs and initiatives through the benefit fund. So whether that's supporting people at local colleges, or kind of delivering a kind of program of STEM activities, so science, technology, engineering and maths initiatives in the local region. So lots of different activities, but and lots of opportunities. And we do have, I haven't got the link today, but if people are interested in careers, we've got a booklet, the People Behind Offshore Wind Power booklet that we've put together that sets out the different roles, both in the construction and operation phase, and gives you a kind of a look at some of the people working in those roles across Ørsted on different projects, and you can see what their background is and the qualifications that they have. And I think the main aim of that really is to show that there really are people coming from quite a diverse range of backgrounds and expertise that have transitioned or started in the industry. So, yeah.
And thank you. And I guess that you've got 2 sets of skills as well. Some of them are going to be involved with construction, which is going to be a long-term project, I presume. You said, I think, that you hope to start for something like 2023. Roughly how long will the project take to be constructed, roughly?
So in terms of our project, so the onshore, we have a maximum of 30 months for the onshore cables. I think it's 36 months for any compounds and 36 months for the substations, obviously as a maximum envelope. And then from there we move offshore, but that could be split into a maximum of 2 phases. So that 30-month or 36-month duration could be split with a sort of a 3-year gap in between, and that will really depend on whether we choose to take forward one project at one time, or we choose to build out effectively what could be 2 projects in one project, build out at one time. And then the offshore kind of extends for I think it's another 3 or 4 years. But we generally undertake the onshore works first, and then we move offshore, so that obviously when the turbines are ready and connected, they're ready to just plug in plug in. I say that very flippantly, but plug into the onshore cables and into the substation, so we're ready to power up.
Yeah, so it's quite a lot of time going to be spent with construction over many, many years, really. And then also, I guess there'll be people who will be continually employed for maintenance and monitoring and things like that as well. We've got another couple of questions here, which were sent in advance. This is quite a technical question. I'll read it to you, but I know you both had this for, as I said, about just 24 hours or so. So I'm not sure how much of it you'll be able to answer, but I'll read it to you. This is from Mike G4DYC. What ranges of frequencies are likely to be affected by any such radiation? Are any particular ranges or frequencies likely to be affected by such radio emanations, such as the fundamental or harmonic frequencies? For example, within the ranges of, and he says ITU classification, so these are the sort of frequencies that we're interested in as amateurs. So 2.1, the low frequency of 30 to 300 kilohertz, medium frequency of 300 to 3000 kilohertz, a high frequency of 3 to 30 megahertz, VHF frequency 30 to 300 megahertz, UHF frequency 300 to 3000 megahertz, and higher frequencies above 3000 megahertz. And he has put there, all of the above frequencies include traffic of communications, broadcasting, research, medical, astronomy, weak signal experimentation, etc. And all the above include allocations for licensed amateur radio stations who use much lower power than broadcasting, etc. So we're dealing with very weak signals through an already high background noise level in many cases. So I don't know, did you manage to get any response on those specific points?
So I think this obviously thank you for the question, and I think it maybe links into our kind of earlier assessment that it's really useful for us to kind of understand the frequency bands that you're interested in as a group. It's not something that we've been able to kind of get the information on just yet, but we can certainly take this away and come back to the group, either kind of providing an update in writing via your community newsletter, or directly to Mike if you want to reach out to us via our project email. It is something that we will need to take away and discuss with kind of potential suppliers to kind of better understand and be able to come back to you on these questions.
Yes, thanks. We will do. As Simon has actually pointed out on a Facebook group as well, that all our amateur frequencies are all in one place. In fact, on the RSGB know those, so we can refer you to those so that you can see the whole of the ranges that we're particularly interested in for our hobby. And a final question that's sent in advance was again from Mike G4DYC, question 9. Are there likely to be any type of power conversions as between DC and AC power using switch mode type power systems? If so, where will they be located, and what are the likely electromagnetic radiations from these power transfer conversion systems? Having regard to the ITU classification of frequency bands in question 2, the other question that he asked, that is, for example, there may be low frequency emanations and radio interference, but also with very high levels of harmonically related or broadband radio noise, such as happens with domestic industrial use of switch mode power supplies. Even small switch mode power supplies voltage conversion systems can radiate high levels of interference, either direct or by coupling into the mains electricity distribution system. And are there any test results from any experiments with regard to this, as any power transfer system to be used in a network system you're likely to employ will be at a much higher voltage, and there would be possibly much higher interference than exists at present? And in advance he says thank you for your talk and for any practical, understandable technical information you might be able to give on the above. Now I know you said you would be able to send some specific information to Mike, but have you got any sort of general reply that you could give to those questions about interference, really, if I can sort of summarise it into that? I think it's the again, great concern that we have as radio amateurs about the interference that might be caused by the technology to convert, if it is a DC link, back into AC. Did you have any other research or any replies rather from your engineers?
I think at this point, I mean, we've talked a little bit about how, for AC technology, we've obviously, we've got a number of wind farms using alternating current in the UK. DC is a newer technology for Ørsted, and we haven't. This will be our kind of first project if we go ahead with the DC that we're using DC for a wind farm in the UK. and for that reason, for us, we need to have kind of those further conversations with those potential suppliers. I think the other things that, that distance from the location of where the equipment is, and it'd be useful to have those, the link to the frequency bands, but it will need to be something that we come back to you on. We are still very much at an early stage in the development, and it's something that we can hopefully provide some more information on once we've had those further technical discussions with the potential suppliers, which we expect to kind of have over the next year or so, in advance of any construction commencing. So I'm sorry we're not able to give a more detailed response this evening, but we will, as we've said, take that away and explore it further with the group. Okay,
thanks, Emily. Yeah, I mean, I think this is the fundamental thing probably in there, although I'm no expert, of course, on anything like this, but is, if it is, whether it's DC or AC that's transmitted or used is the form of power that's on there, is going to be fundamental to what is needed at each end, isn't it? So anyway, thank you very much for answering all those specific questions where you can. We will give you people's email addresses as well if they want something specific. And you can come back to us on other information, although I'm sure the whole group, our club, would be interested in a lot of the replies, and we'll be able to keep in touch with them if you can keep in touch with us. We have got a few questions that have been asked here. If you can, excuse me, if you can answer them, that would be appreciated, but we totally understand and why you needed to ask these questions in advance, because by its very nature, it's quite a technical subject, and you needed colleagues to help you on this. So I will start though with a general point. Firstly, from on Facebook, Nigel Lake says, how will this affect fishing boats, crab boats and other vessels? Do either of you have anything that you could answer that on that? I guess we're talking about the wind farm now.
So without being the Offshore Environment Manager, so I know that we, for example, have 7 vessels out at the moment, and generally we look to cooperate with the fishing industry to understand when they might have fishing gear in the way or when they might be fishing, and we look to then coordinate with them. Unfortunately, we do have to ask for, when we are doing certain types of surveys, and when we are obviously undertaking construction in the coming years, we obviously, for health and safety reasons, it's quite a serious risk if fishing gear or fishermen are in the area. So I don't know the details specifically of what sort of clearance we ask for, but we do undertake what's called an evidence-based approach to providing compensation for that, and as you can imagine, if fishing gear or other boats are in the area, when we've got our SOVs out, our huge or our jackups out, that's effectively just a risk to life. So, and health and safety is first and foremost in our minds when we're building these wind farms and indeed operating them.
Okay, thank you, Ant. I've just got one. I'm going to return to some of the questions there if we can. Just one other question though, I think that maybe other people are thinking as well, is for this project, presume you submit bids, and have you been given what we would call in regular domestic setting sort of planning permission already on this, or is it something that you still need to seek, given that some of the aspects of the project, like the method of transmission of the power, is still to be decided? So can you just tell us how that process works?
Sure. Do you want to take this, Emily, or shall I? I don't mind.
Just very generally,
So great. So we have been given development consent. So it's called a development consent order. So we were awarded it actually on the 31st of December last year. So to get to that stage, you have to have been earmarked a nationally significant infrastructure project. So that means that we undertake we basically use a planning act as the regime through which we attempt to consent the application, and that effectively means that you take the community and there's an extensive consultation with various stakeholders and with the community, and you take into consideration not only the technical aspects, the environmental aspects, but also the landowner and community responses into your design. After that, you then, like I said, I sort of touched on earlier, you then, once you have different levels of design, you go through another consultation, which is called the preliminary environmental report consultation. Effectively, it's called Section 42 of the Planning Act, and you undertake, you basically look to get further feedback, you refine your design a bit further, and then you also refine your environmental impacts at that stage. So you identify potential impacts based on your design, but you look to mitigate as much of your design in the first mitigate as much of your environmental impact in the first instance via your design. You'll then undertake your environmental impact assessment, which is forms part of what is called the environmental statement. You have a project description which sits alongside it, and that tells that informs the assessments that have taken place. So the technical specialists will look at what is in the project description. So that's everything from the width of the cables, the anticipated depth, the number of cables, construction methodology, how many hedgerows you're taking out, where your access tracks are going to be. So that level of design, so it's quite a lot, as you can imagine, for such a big project. And the same is undertaken for the offshore as well. So we have the array, and you'll have your indicative design for where you'll place the turbines, and you'll have your indicative area for where you'll lay your cables, for example. But as you can imagine, to kind of hone in that detail, quite a lot of surveys and detailed information is required, and there's still quite some uncertainty. So your project envelope, your project description allows for a certain amount of manoeuvrability, and that kind of acknowledges that by the time you've gone through the consenting process, technology might have advanced, you won't yet have your principal contractors on board, and your principal contractors will generally you'll give them the project and say that this is what you have to design, this is our business case, can you tell me how you're going to design it at X cost? And obviously we have an obligation to the consumer to kind of reduce that cost as much as possible, and it's not possible to refine and absolutely nail down all of that detail so early on in the process. So when you're given consent, you are given consent to build within certain parameters, and then once you're given consent, you then move into the detailed design stages, and you understand, look, actually now we're moving into construction, we're closer, like I said before, what capabilities do we have for manufacturing these cables? How big can we actually transport these cables, and how big are cable drums can we sort of transport these cables? Where are we going to get our transformers from? How are we going to transport them, ship them? Where are we going to assemble our base? So all of that stuff, as you can imagine, there's lots of moving parts. It's just not possible to get that done 5 years, 6 years prior to construction.
No. Okay, I can understand the scale of this, even just talking about where you're going to get cables manufactured and things. It's mind-blowing, really. We'll try and get through a few of these questions. I know we said we'd try and finish around about 9. So if you can answer any of these, that would be great. Robert G4DUK on Facebook, on BATC says, why come onshore at Weybourne when it is on latitude with Humberside and much nearer, he says.
So
we're partly driven by the connection point we're given. And that's the connection point to the grid network. Unfortunately, we don't really have control over that process. So then what we look to do is you effectively look for, right, where are your constraints? So you look for the shortest route from the array to your onshore substation, and then you kind of start wiggling your route effectively, again, to put it crudely, around all the different constraints. So not only do we have onshore constraints, so obviously in terms of roads or communities, towns, and we generally like to stay away from those as much as possible, and local wildlife sites, triple SIs, all that sort of thing. Offshore, we have huge areas of the coastline which are now designated, and we've got SACs, so special areas of conservation, special protected areas, marine conservation zones. So we have to sort of navigate all of these areas but obviously then need to make the project economically viable. So the shortest route is the first route, but then we start navigating all these constraints, and we'll generally look to find an area of the coastline which is less, ideally not designated, or we'll look for evidence of there being be able to directionally drill, or they're not being fast eroding cliff lines, and avoiding towns and all that sort of thing. So all of those constraints kind of feed into our design and where we choose to make landfall.
Okay, thank you. I'm going to try and keep some of the questions just to the more technical things, because that's really what we're about here as radio amateurs. Well, the next question was, are these projects generally commercially... Sorry, this is from Feathers McGraw. Are these projects generally commercially profitable, or do they rely on subsidies to make them viable?
So I'm happy to take that one. New forms of all new forms of renewable energy do require kind of some form of subsidy, but hopefully, as I kind of covered in the presentation, the amount of subsidy that the projects required, particularly for offshore wind, has dropped significantly. So it was much higher when the industry was kind of in its infancy, but now we've seen kind of these significant cost reductions across kind of new projects, and actually the projects that went through the kind of the most recent contract for different auction, which was a couple of years ago, some of them were coming in actually lower than the predicted wholesale price. So in those projects we may be giving back money almost to the consumer. So we are seeing kind of the amount of subsidies that projects require is significantly dropped, and they are now very competitive. But the regime is still, the kind of contract for difference regime is still very important in terms of providing that kind of stable revenue income for new projects. And as we've talked about, as you can see, they require a lot of significant upfront investment in the infrastructure itself. So it's still kind of an important area, but obviously one that less and less support is required over time.
Okay, thanks. Just if I can, two more quick questions. As I said, I'm going to concentrate on a couple of people who we haven't asked questions yet. Paul McGee says, with global warming, what if we don't get any wind, and what is the minimum wind needed to operate a turbine when you look out to sea? Because he says half the turbines don't seem to be working.
Interesting question. I don't know off the top of my head the minimum wind speed. I don't know if you do, and
no. But what I would say is that not sure about which wind farms. Obviously, you do get environments or times at which the wind isn't blowing. Fortunately for us, the southern North Sea and the North Sea, obviously more widely, but the southern North Sea in particular is some of the best environment. Is one of the best environments in the world in which to have offshore wind. So we're quite lucky in that respect, because it's what you're looking for is a reasonable seabed depth, and although it's getting slightly cheaper for us to build in deeper sea depth, so before it was sort of more commercially viable at around 30 meters, we're kind of getting into the 40-45 meter depths where it's becoming more commercially viable, but you have basically a perfect environment for offshore wind, which is pretty consistent. I can't speak for everywhere in the world, but we're quite fortunate in the UK that we have the opportunity to go green in such a big way. Obviously that doesn't come without its challenges environmentally, but on balance, I think, yeah, we've got it pretty good. We've got an easier fix than I think a lot of other countries potentially.
Okay, thank you. That final one, if I may. Will the cables be used for data transmission? That one from Gia SDU.
So the cables themselves won't be used for data transmission, no. So what we do look to do is install fibre optic cables, like I said, in the cable circuits, but that is purely so that we can monitor the cables remotely. And as you can imagine, that kind of saves time, money, cost, and I suppose, will allow us to foresee any issues. Wind farms in general have a really strong record of not having things really go wrong with them. That's the only sort of communications technology that would be laid with the cables, but that's solely for the operation of the wind farm.
Right. Thank you both very much for taking those ad hoc questions, because I know you were concerned, and understandably, that this is such a massive sort of technology and a whole range of project, and as well as the environmental concerns and everything. That's why you asked for the questions in advance. I know you're going to answer some of the questions in advance, and because this is such an early part of the project, I'd love to think that in a few years' time, when you've got more of the design done, that maybe you'd like to come back to us and see us and update us on the project. We will certainly feed back to you the details about the frequencies and the bands that we work on. That will be very useful. I said, and I'd ask you to keep in touch as well, if you don't mind.
Definitely, and hopefully, as you've seen, we will have, as we enter into kind of the pre-construction phase and then construction, a lot more open communication channels through the newsletters. The website will have more frequent updates as the project progresses. So for anyone who's not already signed up or doesn't receive them, you could do that via the website, and there'll be more updates to come. So thank you very much for having us, and I hope we've managed to kind of answer most of your questions, but we will follow up on those other ones as well. So.
Okay, yeah, well, thank you. And as you can see on the screen now, the website is there, and I will be putting that, and also an email address that you can contact the team directly, and lots of the other links of interesting stories and a couple of videos, as you say, which will be very interesting as well. I'll be putting that all in the newsletter this weekend under the club news section, when we have a sort of follow-up on tonight's programme. But tonight, Emily and Anne, thank you ever so much for spending so much of your own time into this evening, and thank you for being candid and giving us as much information as you can on this. And we really do look forward to keeping in touch with you and finding out the progress and discovering the progress of the project into the future. But once again, thanks very much to Emily and Ant from Ørsted. Thank you.
Thanks, David.
Thank you.
Thank you. There we are. Thank you very much. So, as I said, any more information, you can either come via me and I will forward it to them, or if you want to talk to the team directly, just give them a little bit of time to obviously get the information and things from the engineers and the project managers. Just bear in mind that it is quite early days for this project, so some of the answers, like whether it's going to be DC or AC even, things like that, they don't really know yet. But we're very grateful for their time this evening, so thanks once again to Emily and Ant from Ørsted. Just a reminder then, what's coming up this week on NARC for this Saturday, we've got the Koblensked at 10 o'clock on 7.135 megahertz. GB3NB is the place to go for the GB2RS News on Sunday at 7 o'clock. On Monday, the Monday Night Net at 7:30, again on GB3NB. It talks about food and where would you go right now for your perfect meal. 8:30 is the 80-metre CW Net on Monday, and on Wednesday next week on NARC Live, the hail cycle and the effect that will have on propagation and our hobby. And that's with Dr. Scott McIntosh. So we look forward to that. And don't forget as well the other thing about the wildlife special, 2 weeks tonight, Nature and Wildlife Spring. As someone put on Facebook earlier on, have we really had spring yet? It doesn't felt like it the last couple of days, has it? But do try and capture those images on your phone, on your camera, whether they're video, whether they're CCTV maybe, or whatever. We'd love to get them. You can start sending them now, and the evening will be an interactive evening in 2 weeks' time. And as always, send us all your details and your stories and everything else for us to radio@dcpmicro.com. And if you have just come across us by accident and want to know more about our club, this is the web address where you can find more information about our club, and also of course there'll be that follow-up to Ørsted's presentation tonight with all the links and things for other information that you can get on that project. But that is about it from Tammy M0TC.
Goodbye.
And from me, David U7ERP. Take care of yourselves. Get on the air to care. Bye-bye.